Hello, 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 everybody. Root Beer here with question number 23 on the 2007 Pascal paper. We are at the halfway point of the Part C questions. These are the last 5 questions on the contest. They're a lot harder. They're worth more marks. So let's hope we do it well. Let's take a look at question 23 here. In the diagram, 2 circles, each with center D, have radii of 1 and 2. The total area of the shaded regions is 5/12 of the larger circle, the big one here. What is a possible measure of angle ADC? Now, why would they say a possible measure? Well, maybe there are 2 possible answers to get, but only one of them is represented here. I notice all these answers here are 90 degrees or above, so maybe there's some way to make this work with an acute angle. I don't know off the top of my head. So, or maybe they're just saying, well, you could measure it this way or measure it with the reflex angle. All right, well, let's draw a picture and let's give a name to this angle. It seems reasonable. So we'll have A up here, C over here. We have our smaller circle in here. We have D. And there we go. All right. So I'm going to color code some shaded regions here. So there's this blue shaded region here. Purple shaded region. Now the blue and the purple add up to a certain amount. But I think I'm also going to need this orange region in here. And I'll explain that in a moment. Now let's call this angle theta. All right. So, we know that the radius of the larger circle is 2. And we know the radius of the smaller circle is 1. So, the large circle has an area of pi r squared, so that's pi 2 squared, or 4 pi. So, our shaded area, so specifically that's the blue plus the purple, is 5/12 of this large circle area, 4 pi. And that's 20 over 12, or 5/3 pi. Okay. Now, we can figure out what the purple area is. So the purple area is just 360 degrees minus this theta that I have set out, minus this theta that we want to measure. And in general, if I have a circle, and I have a sector of it, so here's the center of the circle, and I have a section of it that I want to know the area of, and I know the angle here. The area of the sector is, assuming we're measuring things in degrees, the angle divided by 360 degrees times the area of the circle. So we'll call this r, pi r squared. All right, so if I wanted, say, the purple area, would be 360 degrees minus theta over 360 degrees times pi r squared. But r in this case is 1 because it's the smaller circle. And we can do a lot of stuff with this. For example, the 1 squared doesn't really matter, so it's pi. We can separate it to 360 over 360 minus theta over 360 pi. But 360 over 360 is just 1. So this is pi minus theta over 360 pi. And we're starting to get a better idea of where theta fits into these things. Now, if I wanted the blue section, I don't have a formula for just a random piece of the big circle, but the blue shaded area plus the orange shaded area, and this was me thinking ahead, is a sector of the circle. Together they form the sector of the big circle that has angle theta. So theta over 360 of the big circle, so that's pi 2 squared. You might say, okay, well, yeah, but how can we get rid of this orange section? What can we do? Well, the orange section is a sector of the smaller circle. Theta of 360, and then pi 1 squared, or just pi. Okay, so that tells me that the blue slice is just 4 pi theta out of 360 minus pi theta out of 360, which is just 3 pi theta out of 360. So now I know that 5/3 pi is the blue plus the purple, and the blue is 3 pi theta over 360, and the purple is pi minus pi theta over 360. And so that's going to be pi minus 3 pi minus pi is 2 pi. So this would be plus theta out of 360. And we can start to calculate. We're going to need a little bit more space for our calculations. But we have 5/3 pi is pi plus 2 pi theta out of 360. Now one thing we could do is divide through by pi on both sides. 5/3 is 1 plus 2 theta out of 360. Something else we can do, multiply by 3. Maybe we don't like fractions. We got 5 is 3 plus 6 theta over 360. Subtract 3, we'll get 2 is 6 theta over 360. Multiply both sides by 360, we'll get 720 is 6 theta. Divide by 6, we'll get 120 is equal to theta. And if you need to, of course, for all of this, you can use your calculator. But we get 120 degrees is going to be that angle theta that we wanted. Okay. And that's going to be an answer of B. So there we go. We got 2 more questions to go. Question number 24 will be up next. Join me in the next video for that. Until then, have a wonderful day, take care, and thank you as always for watching.